Okay, so we're going to go through our control software for our Gantry robot controller, the sort of first version of that has cropped up in the second video on that project. And we say in that video that we'll go through line by line, so we're just going to describe all that here. So the first thing we're doing for the Arduino is just declaring our servo objects and then declaring our variables. And our input variables are the link 1 angle, the link 2 angle, link E angle, which for us is our end effect. These are the potentiometer values that it's reading in, and it then maps them to the servo positions for link 1 angle to link 1, link to link 2, and link E angle to link E, which is our end effector servo. And then we have our declarations for our safe working limits joint 2. So joint 2, the safe working limits are determined by the position of joint 1, and those are declared here. So we pass into this function that we've written the value for joint 1, and it calculates the minimum value that joint 2 can safely be at. And for this one, it does the same thing, but for the maximum value. And we can just look into them quickly. Our joint 2 min, we pass in joint 1, and it uses the value of joint 1 plus 35, which is how we found that it seems to work for the envelope, or 0, and it picks the higher of those two values. So negative joint 1 plus 35 and 0. So this is our table of joint angles. So if we take minus joint 1 and add 35, we've got minus 10 add 35 is our minimum value for joint 2. And the same here, and then we get to this point where we just end up with 0 for our minimum values. So what this is doing is it's returning the maximum value of either minus joint 1 plus 35 or 0. So that means the maximum value between minus joint 1 plus 35, which in this instance is 25, or 0 when we get down to here, because minus joint 1 would be minus 50, plus 35 would be minus 15. So it will then return 0. And we have a similar sort of thing for joint 2. We pass in joint 1, it takes minus joint 1, adds 170, or 110, and it will return the minimum value of either of those things, argument 1, argument 2. And so that's how we get our maximum values out. Once we have our minimum and maximum values for joint 2, we go on to declare these two functions, which are essentially our main control loops. And these are determined by a toggle switch sort of on the robot. When the toggle switch is off, it will just do the sweep of the workspace, and we did this purely so that we could have that sweep running for the other video where we've overlaid the workspace onto the actual robot. And if you haven't seen that, that's worth a watch. And then we have controller input, which in our main loop, if the switch is on, run controller input, else run workspace sweep. And that's our entire main loop here. We also have our setup where we just attach everything. This is a sort of Arduino syntax, serial begin. We detach all of our servos and then we reattach them, and this is just to make sure that they're clean attaches. And then we have our pin mode declarations. And then into our controller input loop, which is what's called here. So if the switch is on, if we've turned the robot on for controller mode, run controller input. And controller input will run. And in this we have link 1 angle, link 2 angle, and end effector angle read in from our potentiometers, which are on these pins. These then get mapped to our servos. And really this is our code here. This is it. Read in the values, map them to the servos, and then send that straight to the servos. And we've got a 15 millisecond delay just so that things can kind of catch up. And that's the entire control loop. So as you move the potentiometer, it will move the arms, and that's it. I hope that's helpful if you're going to try this yourself, and let us know if you have any questions. Thanks.